Okay, welcome everyone. Today I'm going to have a lot of fun doing this talk. And I'm going to be talking about maybe something that you never imagined that would happen. And I think it was after the summer that I come across about OpenAI and some of the experiments that were happening last year. And obviously, I got a little bit shocked when I realized that the people in artificial intelligence, without almost knowing nothing about programming languages, I mean, they know Python, but not JavaScript, probably. And they just did amazing progress in coding. And I was just amazed. So I stick into the topic. I said, okay, let's go, let's investigate. It cannot be that difficult. But it took me a few months, and this is the result. So it's going to be a lot of fun. And this is my opening, the AI that may overtake humans. I was going to use developers, but actually it could be anyone. I mean, everyone is at risk now. It's not only developers. So this is my name, Gerhard Sans. I'm originally from Barcelona and living in England, in the countryside. During the pandemic, I started doing open swimming, and this is last winter. And for some reason, I brought everything here for this trip. So maybe later during this week, you will see me doing more pictures like this. Hopefully the temperature will be warmer. Okay, so I'm an international speaker. I've been doing this for a few years. I think this is my 4th time at Jfokus. And I'm working on several things. I mostly do front-end and cloud. And this is a training that I'm doing with Yang Kui. He's an AWS hero. So let's go right into the first question. So what would happen if an AI could do your job? Is that good news? Is that bad news? How long do you think it will take? Few years? Few months? What's your guess? Never? Okay. Let's see what Elon Musk has to say about this. AI is likely to overtake humans in the next 5 years. No reaction? Okay. Well, this is the opening. So I'm using the words from Elon. And actually, I think he might be right. It's a little bit scary like that. So let's talk about OpenAI. This is a company in San Francisco. This is their logo. And this is a company that was founded just a few years ago by Elon Musk and some people from the AI community. And this is how they present their mission. So our mission is to build safe artificial general intelligence that benefits all humanity. It's a little bit intriguing, the phrasing of it all. Do they know something that we don't know? They are playing with marketing. They are trying to hype it. Let's see. In 2015, they created the company, and it raised a large amount of money, $1 billion. Few years later, GPT model was released, and this is the first, what is called a generative pre-trained transformer, with just 117 million parameters. This is a figure that I'm going to be coming back, but this is more or less the size of the model, to give you an idea. So this was the first release. This is just a few years back. In 2020, they released GPT-3, the third iteration, and they also opened the API, so anyone could use it. This was the largest model at the date, and it was 175 billion parameters. If we look at the parameters, it's probably all the connections that the model is able to keep in the same context. I don't know how many things you can keep in your mind, but can you imagine keeping 175 billion connections? What could you do with that? 2021 was a great year, and this is when they released a product. And the first product is GitHub Copilot. GitHub Copilot is using GPT-3, a version of GPT-3 that is called Codex, specialized in code. And they also released some other things, like DALL-E. Maybe you have seen images created by DALL-E these days. These models were a little bit smaller, just 12 billion parameters, but the results were quite astonishing. Let's see a comparison with all of the different models that exist, some from GPT, OpenAI, and some from other companies in the space. And you can see that in just a few years, we have seen like an amazing progress. So we started with GPT-1. You can see in 2018, very small. This is a logarithmic scale, just for you to notice. Then GPT-2, just a year later. 2 years later, GPT-3. And a little bit later, Codex. There's other models that compete with GPT, but I'm going to just focus on OpenAI. But you can see the sizes just keep growing and growing and growing. So when I'm going to show you the demos and what OpenAI is doing, you can also imagine what other companies are doing at the same time with larger models. Okay. I'm going to use this to break between sections, so get used to it. A lot of cuts. Let's talk about GPT-3. And here, I'm going to look at the details. You don't need to be a mathematician or anything else. And I hope you will follow. I'm introducing also the grumpy cat to make it a little bit more fun. And this is what you would deal with if you try GPT-3 and you go to their public playground. So we can see here what is called a prompt. And this is just some natural language text. Then we have some hyperparameters, so we can configure how GPT-3 responds. And then basically, with this information, GPT-3 is able to generate text that continues from the prompt that we presented. And here is the text that I just used. The day started as any other day. I give no context. GPT-3 just kept going with a couple of hours of intense work before lunch. Sounds good? What do you think? Would pass? Okay, Grumpy Cat is not amused by this. Let's see another thing. The thing that happened with OpenAI is that they trained this big model, didn't know what was capable of until they opened it to the public. And then a lot of people started trying things. And then they figured it out that it learned things that they never expected. And one thing that they saw is that GPT-3 was able to capture patterns and not only generate text, but follow patterns like question and answer, like a chat. So you could just add a question, and GPT-3 will come with an answer, give you the answer, and wait for the next question. And of course, that raises a lot of, like, what? How? I was expecting to generate text, but not to figure out a context of a chat. One thing that they realize is that as they keep testing the model and asking more questions, the model also gave funny answers, like this one. I think the term is hallucination in AI. So the model was hallucinating. Yeah, that doesn't look right. So one thing that you need to pay attention when you play with GPT-3, if you go to the playground or if you see examples online, is that it has some issues. These are the main issues that the community has found by using GPT-3. And the first one is probably one that we have seen in other areas in AI, and is that depending on the training data, you will find biases, but these are because of the training data. I mean, that's not much you can do about that, unless you get more quality data for the training. The other thing is that you may get non-factual results, and also inaccuracies. These are mostly in arithmetic. I mean, some people ask GPT-3 to do arithmetic calculations, and most of the times is able to answer, but sometimes it also gives you inaccurate results. But it's quite of worrying that it guesses, I mean, it gives you some correct answers. So how does machine learning work? GPT-3 go through different stages. There's a design, and GPT-3 was designed using transformers, which is a technical term of the architecture that is using internally. Then it goes through a stage of training. And actually, this phase is quite important because the model will be able to produce results as good as the quality of the data during the training. If you think about a good example, would be learning from a chef or learning from your neighbor. So if you learn from your neighbor, maybe you will learn a couple of recipes. If you learn from a chef, you will learn from the best recipes. So GPT-3 is just the same. And then once the model has gone through design, tweaks, then training, more tweaks, then it gets into the stage of predictions. And this is when GPT-3 is released, and then people start using it. So let's look into how some figures on GPT-3 model. This was released just a couple of years ago. And the training data, just so you think about what kind of data the model can use to give you the results that it does, is a common crawl. This is a technical term for just going into the internet, downloading whatever you get from URLs, and then parsing that information and passing that information through the model. Then, I don't know if it's a good idea, but they also got the information from Reddit, which is mainly users, like a user group. Some how it's called, books, like classic books, all sorts of books from the last 200 years, publicly available, of course. There's copyright issues in that. And also Wikipedia. I mean, Wikipedia probably is not the best source, but I mean, these are sources that you can access publicly. So that's what they did it. So the results that I was showing you before were with this data. That was the training data. So that gives you an idea of what it can achieve. Of course, if you get much better data, then you get much better results. These are some figures that we covered before. Just maybe mention the dimensions. So these are the relations between the different concepts that the model is able to keep at once, which is very impressive. I remember when I was doing my research, I asked some of the leads in AI, I'm not going to mention the names, and I asked them how many relations you would need, like generalizations of language, to be able to reason around a language like English. And if you think about that, it's not much. It's maybe 5 different levels of abstraction. It's not 12,288. It's maybe less than 10. If you think about it, it's not that many levels. And the data that they used was only half a terabyte. So imagine if they put more money and more computing effort. All right, so this is a little bit of the percentage and also the number of tokens that GPT-3 deal with. And most of it is the internet. So it could be anything. It could be recipes, it could be marketing, it could be e-commerce. These are the top websites, but I mean, of course, if you pick 1,000 top websites in Alexa ranking, you're going to get everything. So actually, that means that you can go to GPT-3 and ask business questions, or ask for a recipe, or ask anything, really. One thing that they realized, testing and asking questions and playing with GPT-3, is that with the training data, which was mainly crawling the internet, it learned more than 100 languages. Nobody teach anything to GPT-3. I mean, GPT-3 went through the training, but there was no specific training on learning French or German. There's not even a lot of data in these languages. So you can imagine if you train GPT-3 in German, specifically in German, it will be amazing. Right now, GPT-3, it's mainly in English, but it can translate in all of these languages that you can see, without being trained specifically, just crawling the internet. So how that works, how that training works. So I'm going to show you how GPT-3 learns, and I'm going to use an example of, we go to an article in Wikipedia, GPT-3 starts galloping the content word by word, and we see how GPT-3 adjusts the model and makes the modifications to keep learning. So we got the article in Wikipedia, and then the training from GPT-3, and then the output, which is kind of a prediction of what will be the next word. Because GPT-3 at this stage is guessing what will be the next word, and then because it's trained in that exercise, it can also generate these sequences, which is what I showed in the demo. So let's pick this Wikipedia article, and GPT-3 goes to the first word, Christopher, and tries to guess the next word, and comes out with is. But it's not is, because the next word is Columbus. So that was a mistake. So it adjusts internally, and it does it again. Now I have Christopher Columbus. What is the next word? I'm going to say was. Okay. It wasn't, so it was a fail. It adjusts internally. And for the next one, it guesses America. And now it's a good guess. And it keeps going on. So as you can see, there's no much magic going on. GPT-3 can go through the text of these articles, the crawling, and all of the books from hundreds of years ago, and just keeps updating using that information. What is happening internally is that it's creating this hyper-dimensional graph. And I'm going to show you how that works. So here we have one word. As GPT-3 keeps reading, it's now using another token, which is. And we can see there's a new relation between these two. That was because it was on the text. Then we also have America, which has a little bit more weight, and that's why the arrow is a little bit more thicker. And each of these dimensions is one of these arguments that the model is able to keep. Then we have discover, that's another relation, and so forth. If we look at this hyperdimensional graph, of course, the quality of this graph will be depending on the training, as I was explaining before. And once we have this finalized model, we can also label these different dimensions. And of course, there's no representation that I can use, but this is the closer that I can visualize in a slide. I hope you get the idea as GPT-3 is learning. Okay, this is visualization. Let's see if we can get it open. Okay. So this is how it looks. If we looked inside GPT-3, this could be a visualization. Of course, this model is a little bit smaller. This only has 200 dimensions and 10,000 data points. But I'm going to use Columbus. So this model also has Columbus in their training. And if I run this query and isolate the points, you can see what I was showing you before in the previous slide. So we have these different dimensions that link different terms and concepts. Here we have, for this data set, we have Christopher, colonization, somehow Ohio, voyage, and Cincinnati. Oh, there's a city called. So it depends on the training data. As you can imagine, there's no consciousness or anything. It's just the data that was used for the training. But you get an idea. It just builds this hyperdimensional graph. Then you have terms that are closer somehow in this hyperdimensional universe or space. And this is how it works. One thing they also realize, because it's crawling, it's using the crawl of the internet, it learned how to code. And somehow, if you add a command, this is a JavaScript, so if you add a command, it's able to create a function. It understands that what follows a command in JavaScript must be some JavaScript. And somehow, in this hyperdimensional graph, the learning of JavaScript is in there. Okay. So you can imagine how surprised the team at OpenAI was after seeing this. Like, oh, we trained GPT-3 to write text, and somehow it learned to code JavaScript? That's weird. How did this happen? Of course, a lot of the people working in AI, they are not so much developers, but when they find a discovery, they keep digging. So what they did, what do you think they did next? They said, we need to change the training data. Make it specific to this problem. So that's what they did. One thing before we get into the code is GPT-3 can do a lot of things. It's very versatile. It can be used to write text, of course, writing tools. It can also be used for creating a chat, which is called Conversational AI. It can also be used for coding tools, as I'm going to show you very soon. Translations, somehow it can translate between languages that it has learned. It can also do summaries, so you can show a whole article and write in the prompt, I want a summary for a 5-year-old kid, and it will do the summary. Why not? Or you can ask for instructions. How can I cook a chocolate cake? It will give you the steps. It's a little bit freaky. So that was my reaction, like, what else can it do? What else can it do? It's kind of a mystery. The thing that you need to imagine is that the space of this hyperdimensional graph is so large that nobody has explored it. We have just explored few use cases, but how many other use cases are there hidden in this massive universe? Nobody knows. Codex. So what happened, OpenAI did the examples so that, oh my God, the model is generating code. Let's try if we give it just code. So August 2021, that was last year, they said, look, let's get GitHub, let's get all the GitHub and just use it to train GPT-3 using the same architecture, just clean slate, instead of taking the internet crawl and instead of taking the other training data, just code. We're going to get code from GitHub, we're going to parse it, and we're going to get a snapshot. So that's also one thing you need to consider if you play with Codex, is that it's a snapshot. Anything that it's built after May 2020, Codex doesn't know about. So if you build a library in the last few months, you cannot ask Codex to build a code sample. So the data that they pick is 55 million public repositories, why not? And the model is very similar to GPT-3, a little bit smaller, but this time only trained with code. They are not joking around, no books, no recipes, no random content, just code. Okay, and this is more or less the size. It's not that big. If we compare it with GPT-3 that was half a terabyte, this is a much, much smaller. So what did it learn? Well, when they went through all the stages, they did the design. I mean, the design was mostly the same. They did the training with GitHub, and then we put it to test. So this is what they find out. It learned all of these languages. So you can write a prompt, as I did with the JavaScript example, and it can write TypeScript, Python, Ruby, Go, Perl. It can even, you can describe SQL schema, and it will write the queries for you. A little bit more scared about your jobs? Okay, So what GitHub did? Probably from this collaboration, they built the first service, and this was GitHub Copilot. So this is a product, and this is how it works. So you go into Visual Code, there's a service that lives in GitHub, and this communicates with OpenAI Codex, which is the model that uses GPT-3 same architecture, but only for code. And what did they do? They limited the languages, so it's not all of the languages, just a subset. And for us, we're going to look into JavaScript. So mainly what they are offering is, if you get into the technical preview, it will just allow you to just write a code, command, and Copilot will write the function for you. I mean, it will literally write the function for you. Somehow, it learned about the DOM. It learned about the different attributes of the DOM. And also, because it has the GPT-3, like common general language knowledge, you can just give it the instructions you would give a colleague. Like find images without an old attribute and give them a red border. Maybe some of us wouldn't follow the instructions as correctly. Of course, because GPT-3 and Codex have all this information in the model and all the different probabilities for the different connections, it can also give you different options. It's not going to give you one solution. It's going to give you probably 100 solutions. And they also integrated that in GitHub Copilot. So you can ask for a function. If you don't like the implementation, you can go to the next or go to the next until you are happy. All right. Well, is that amazing? Well, it's not amazing enough because just last March, they improved on that and they release what they call insert and edit. And they release it for everything. So they release it for GPT-3, they release it for Codex, and they release it for DALL-E. So now what you can do is you can take a text, it can insert text in a context. It cannot only continue a text, but you can give it a text and insert a text in between, let's say, or it can take a text and take instructions. For example, change the first person to a third person. Change, I don't know, you can do, I mean, I'm not a writer. I cannot come up with examples. But let's see around code. This is, I think, crazy. It can refactor. I mean, before it could create code, but now, because of this new release, it can refactor. So how that looks? Okay, so this is going to get freaky now. So you can give it, you can give it just, this is Python code, you give it a definition, and then the name of the function with an argument, with a parameter, and now is using this edit function. So it sees that there's a definition of a function, it sees how you call the code, and it figures out, oh, you probably want to implement the Fibonacci function, and this is the result. So this is probably how we are going to work in the future. All right, next thing, because it's iterative, you can keep asking things. So improve the runtime complexity of this function. Here we go. As you can see, now it's using, it has add like a catch. So as long as you have the value, you use a catch. If you don't have the value, okay, I'll do the calculation. So it's a little bit improved. The question here, the problem here is who is doing this? Is that Codex? Is that some kind of personal assistant? I mean, who is the person? I mean, who is doing this? I don't think there's an agreement on that, a convention. It's just Codex. Let's see more examples. Because it can translate between languages, like English and French, could it also translate between coding languages? Let's see. Oh yeah, it can also do that between all of the languages that we have seen. Why not? What else? Write this as a one-liner. This is a challenge for Codex. Okay, not a problem. So you can see where we are going. You're a little bit lazy, you didn't write the commands, because Codex has also the capabilities of GPT-3. It can write the commands for you. So you just write the commands, and then he figures out, oh, so you want to write the commands, no? That's what you are trying to do. Okay. Well, it just gets worse. Okay, so this is an open text. Let's see what it can do. This is the latest version now of Codex with the release from March. Convert the list to JSON file with rank, city, state, and hour. So we give it a free text, which is a nightmare, and it just parses the text and creates the different properties and objects. I mean, I wouldn't give you the assignment to create that parser, because that's insane. I mean, this is a problem that has been hanging around for the past few years, and I don't think there's a solution for this yet. What else we can do? We can keep asking things. So why not remove the rank, which is the ranking of the cities, 1, 2, 3, and I don't like to have the state in abbreviation. Can you please expand it to me? Why not? Yeah. Okay, so this is the future. Maybe you work with YAML. Can you just transform this in a YAML? Yes. Okay. What would you do with this technology? I mean, it's completely insane in the brain. Okay, well, let's move. We have text, we have code. They move into images, and this is DALL-E today. That was released last month. Similar thing, we have a prompt, and DALL-E, which is specialized around images, will take the prompt and generate the image. This is a prompt, an astronaut lounging in a tropical resort in space in a vaporwave style. I just broke down the different bits of that prompt. And that's the result. That was the model, which is using a different architecture. This is not GPT-3 anymore, but is a mix of GPT-3 and then also image specialized models. If we change the prompt and we say, can you do it as pixel art? I mean, how generic is that? And DALL-E 2, which is the just released version of this model, comes with that output. Let's do it in photorealistic style. Okay. That's the result. And of course, this is what is the generative part of it, but as you remember, in March, they released the insert and edit. So they also did that for DALL-E. So we have the original, we have a prompt. So we tell DALL-E, I want to modify the image in this location and follow the prompt. And this is the result. Well, I hope you are not in design. We pick another location, and it generates the flamingos. How cool is that? Yeah, that's the, that's the reaction usually. What? Okay, so I took everything that I learned, I went into the playground, and this is my experiment. Okay, let's run it. Okay, this is just a little bit of explanation. This is the playground. It's open publicly. You just need to register, and you have some credits to use this, so you can go later today and play as I did. My objective was to test Codex and find, like, okay, what it can do, what it cannot do, and how you would use it, like in a session. Imagine you are living in the future, and you just got a new colleague at work, which is a coding assistant AI, and you just ask the coding assistant, can you do this? Can you improve this? Can you change that? So this is my exercise, my experiment, and you can write your prompts at the bottom. The result appears in the middle, and you can see the code on the right side. So let's see what transpired from my experiment. So I'm thinking I'm going to start with something easy, like hello world. But I'm not going to say hello world. Add a greeting message to the center of the screen. Okay. And maybe that's too easy. So I'm going to add some like CSS. I don't know if you're familiar. Using flex container. Why not? Let's see if Codex learn about it. And taking the whole screen. Okay, so that's the instruction. Now you can imagine yourself like, okay, I think I got it. Let's see how long it takes for Codex to do it. We can see the code being generated. And here we go, it's done. If you remember from my prompt, I never said what was the message. I left a lot of things open for Codex to decide. Somehow it decided to use this green and this font, which is terrible. I mean, I think that's a joke. And we can see if we look at the code, it's using a flex container, it's setting all of the attributes, it's, I mean, it's, besides the color, it's perfect. Remember that Codex only learned this from GitHub information and also the crawling of the internet. Okay, let's fix some things, like I don't like the font. Change the font to be more JavaScripty. Because I'm playing now not with the coding knowledge, but I'm playing with some general knowledge, like would it be able to pick up what I mean? I don't even know what I mean. Okay. Apparently, Codex know what I meant. Okay, the color is terrible. Let's fix that. Change the font color to be a shade lighter than black. I'm just playing, you know, along. Just play along. Right, yes, that's exactly what I wanted to do. Because if you use black, it's a little bit too, the contrast is too high, so I'm thinking, take the black, but put it a little bit down, so it's not so, you know, it's not so stark. If you look at the actual decision, the actual decision from Codex is 0, 0, 0, 0, 0 is black, so it just took like the next level, like 3, which is a little bit, you know, whiter. So it's a little bit nicer. For all the designers in the room. A little bit nicer. Now it looks pretty neat. Let's go for the next assignment. Create an array of greetings. So I want to make it a little bit more interesting. And now I'm going to use hello. I'm going to be specific. And I'm going to ask Codex to pick 5 languages. So I'm a little bit lazy. I don't want to pick the languages. Just pick 5. And here we go. We got the 5 languages. Maybe it's a little bit small, but I'm going to make it a little bit more apparent. Change the greeting every 2 seconds. And I'm going to do a typo in purpose. Because otherwise it will be too easy, isn't it? So I'm doing a typo. I'm asking something that is not clear what I mean with this. Let's see what Codex does. Okay, so it used a set interval to go through the array every 2 seconds. So you can see now the 5 languages. And here it learned that it's in milliseconds, so it's using 2000. Hola, ciao. I don't know what is that. Hello. Ciao. And it's using a random, so it's picking between these. And I'm going to add a new language. Why not? Add a greeting in Polish. Okay, if there are any Polish in the room that can confirm. Is that okay? Okay, cool. Very good. You did good, Codex. We are almost done. And I wanted to ask a little bit of general knowledge. Change the color of the text to be similar to the one used by Twitter. Can you imagine the color of Twitter? And I'm thinking, well, maybe that's too much. So I'm going to say the blue. Just give it a little bit of help. Let's see what Codex did. All right. So you can also give in like completely random requests that make absolutely no sense. Like you need to know what's the logo of Twitter, what the color it is. And Codex knows about it. Okay, this is the finale. And for this, I'm going to ask something completely insane. So I'm going to ask, okay, take the message, use the language, and pick an emoji that makes sense for that pair. Okay, and the prompt is a little bit more difficult in this case. And I'm saying that it needs to be fun as well. Do you think that it will succeed? Of course, of course. It's not me, by the way. It's not me doing all this on my own. This is a live experiment that I did. So let's see how long it takes. Okay, it's done. It's coming. And here we go. So we got the emoji. We got the emoji matching the language. And there's a problem. There's a problem because in English, what emoji you're going to pick? So I picked the hand. Like, what is going on? What is happening? Okay, well, this is only the beginning. I think I only cover the last 2 years. OpenAI keeps releasing new things. I mean, I don't know where we will be in 2 years. The future of AI is, unfortunately, is today, and all your jobs probably not needed anymore. If you want to try it, you can go and see the demise of your professional career. Here, I ask, like, just for fun, I tweeted this image. Matthias, the organizer, was thinking like, okay, Gerard, you are coming off a little bit too dramatic. And I was like, okay, will AI assistants take over conference planning? I mean, he's concerned about Jfokus. And this is what Codex said. It is possible that AI assistants will take over conference planning in the future. Not a problem. Okay, what can you tell me about Jfokus and what is the target audience? Jfokus is a conference for Java developers that covers a wide range of topics related to the Java platform. That's Codex. All right, if you want to play with it, you can use Copy AI. And yeah, that's all from me. Thank you for listening. If you have any questions, I'll be hanging out. I'll try to answer. No worries.